Hello good day viewers. In this tutorial we are going to talk about the 6 trigonometric ratios and also solve some problems. So if you are new here, consider subscribing, press the bell icon so that you will be notified whenever I upload any content, and don't forget to like this video. Alright, let's get started. Unlike Pythagorean theorem, which only deals with the relationship between the sides of a right angle triangle, trigonometric ratios deal with the relationship between the acute angle of a right angle triangle and also the sides of that right angle triangle. So now let us write the 6 trigonometric ratios and show you how they are related to the right angle triangle. So the first three, which are most significant, we have the sine ratio, we have the cosine ratio, and lastly we have the tangent. These are the three basic trigonometric ratios, and we have other threes which are just the reciprocal of these three. So the other three are cosecant. Cosecant is just the reciprocal of sine. Then we have secant, which is a reciprocal of cosine, and lastly we have cotangent, which is also the reciprocal of tangent, making 6 altogether. So let me show you how they are related on a right angle triangle. Suppose we have a right angle triangle like this. This is a right angle triangle because we have a right angle here, which is angle 90 degrees. Remember, I told you that these ratios connect the acute angle of right angle triangle and the sides of that right angle triangle. So let's start with the sides. Remember that that side which is directly opposite to the right angle is called the hypotenuse. So this is the hypotenuse. I remember in our previous lesson we used to call these other sides as legs, but this time around we are going to call them opposite and adjacent. And how can we determine the opposite and the adjacent? If we have an acute angle here, which we used to denote with theta, a Greek letter, that side which is directly opposite to that acute angle is called the opposite. So this side is the opposite. We call this opposite. And the other side is the adjacent. It is very important to know that the side length directly opposite to the angle theta is the opposite side, because sometimes this right angle triangle can be twisted. For example, you can see something like this. This is also a right angle triangle because you can see 90 degrees here. So what if we have an acute angle here, theta? Therefore, this side length must be opposite. Always the side opposite to the theta or any other letter that denotes that acute angle is the opposite side. Opposite side. And the hypotenuse is always directly opposite to the right angle. So this is the hypotenuse. And this other side will be the adjacent side. So let's start with sine. Remember I told you there are 6. So number 1, sine theta. Sin is the short form of sine. Sine of theta, that acute angle, is always equal to the opposite side, let me call it OPP, divided by the hypotenuse side. Okay, is that this is the relationship between the sine of that angle and the two other sides. So whenever you are looking for the sine of that angle, you can take the ratio of the opposite side to that of the hypotenuse. Number 2, if you are looking for the cosine, cos is the short form of cosine, cosine of theta, it is equal to the adjacent side, let me call it ADJ, divided by the hypotenuse. And lastly, the first 3, the tangent, that is tan of theta in short form is equal to opposite side divided by the adjacent side. And we have an acronym that can always remind you on how to take these ratios. And the acronyms are SO, CAH, and TOA. S here stands for sine, C here stands for cosine, and T here stands for tangent. Then we have the ratio here. Opposite divided by the hypotenuse, adjacent divided by hypotenuse, opposite divided by the adjacent. So whenever you are looking for these three ratios, you can use this to record what ratio to take. Then remember we have their reciprocals. So let's continue. Number 4. We have the reciprocal of sine, which is cosecant. We call it cosec in short form. Cosec of that angle is equal to the reciprocal of sine, which is the same thing as 1 divided by sine of theta. And 1 divided by sine is the same thing as taking reciprocal of this. Just flip it upside down. We have hypotenuse divided by the opposite side. So this will be the hypotenuse divided by opposite side. So if you are looking for cosecant of that angle, you can simply take this ratio. Then we have number 5, reciprocal of cosine is secant, sec, which is 1 divided by cosine of theta. And since we have this to be the ratio of cosine, its reciprocal will be hypotenuse divided by the adjacent side. Hypotenuse divided by the adjacent side. And lastly, we have cotangent, that is cot theta is equal to 1 divided by tangent theta. And this will be equal to what? Adjacent divided by the opposite side. Just take reciprocal of this, flip it upside down, and it will give you the reciprocal. And for a bonus, let me add one for you, though it is the same thing. If you are looking for tangent theta, you should remember that tangent is a ratio of sine and cosine. When we get to unit cycle, you will understand this better. Cosine theta. So this will be, what is sine? Remember, it is opposite divided by hypotenuse, right? Let me use this division sign. And the cosine is what? Adjacent side divided by hypotenuse. And remember, you can change this to multiplication and take reciprocal of this. Thereby, this will cancel this. You only have what? Opposite divided by the adjacent side. So this is opposite divided by the adjacent side, which is exactly the same thing as this. So assuming you don't have anything that will relate these two sides and sine and cosine values are already given, you can take their ratio, sine divided by cosine, it will give you tangent. So these are the 6 trigonometric ratios you should know before you start applying them in solving some problems. So now let us get to some problems. Let's start with the first one here. We are looking for this angle x, and I'm going to show you how to use calculator to find the missing angle. First of all, you should know that that side directly opposite to the acute angle you are looking for is the opposite side, and this one is the hypotenuse. So you can see that hypotenuse is not given, but we have the adjacent side and the opposite side. So what ratio relates adjacent and opposite side? Is tangent, if you can remember. So this, we have tangent theta, but this time around I'm going to use x since x is given, is equal to what? Opposite divided by what? Adjacent. Right? So tangent of x will be equal to what is opposite? Opposite is 3 and adjacent is 6. And 3 divided by 6 is equal to 0.5, right? So tangent of theta, sorry, it should be x, is equal to 0.5. All right, but remember we are looking for this angle. So how can you undo tangent here to leave only x? by taking tan inverse of both sides. So if you take tan inverse of the left hand side, you have only x. Then you take tan inverse. That is the ratio that will cancel this tangent theta. You take tan inverse of 0.5. So how can you take tan inverse of 0.5 on your calculator? First of all, you should take second function. I don't know the kind of calculator you are using, but if you are using Cardio, you press second function. You see something like this, second F, second function. Then you hit tangent. Then you impute the value right here. So that's exactly what we are going to do. Or some calculators may have tan inverse directly. You see that like this, arctangent, arctan. If you have something like this, just press arctan, then impute the value 0.5 and press enter. It will give you the angle in degrees. Remember, we are dealing with values in degrees. So tan inverse of 0.5 is approximately equal to 26.57 degrees. So this is the value of the missing angle right here. So now let us move on to the second one. Okay, but this time around you can see that this is hypotenuse and this is the opposite side. So what is the relationship between the hypotenuse and the opposite side? Is sine. So sine of that angle x is equal to opposite divided by hypotenuse, right? So if your calculator can take fraction, you can use it. I know my own can take that. Just take sine inverse of both sides. You have x here equal to sine inverse of 4 divided by 15. And this is approximately equal to 15.47. 15.47 degrees. So this is the value of x. And here, what is the relationship between the hypotenuse side and the adjacent side? It's cosine, right? So you can say that cosine of x is equal to what? Adjacent, which is 8 divided by the hypotenuse, which is 10. So x will be equal to cosine inverse of that value 8 divided by 10. So according to my calculator, this will give us approximately equal to 36.87 degrees. So this is all about first question here. Let's move on to the second part. So D part, we have the opposite side, we have the adjacent side. Always that side directly opposite to the acute angle is the opposite side. So we have the opposite, we have the adjacent. Therefore, you're going to use tangent. So I'm only going to write it for you. So tangent of x is equal to opposite, which is 12, divided by the adjacent side, which is 9. Then you take tan inverse, x equal to tan inverse or arctangent, all the same, 12 divided by 9. If your calculator cannot impute fractions, you can simplify the fraction first before you take tan inverse of that value. Do the same thing here. You can see that this is hypotenuse. This is opposite side, is not given, but this is the adjacent side. So what is the relationship between the adjacent and hypotenuse? Is cosine. So cosine of theta or x is equal to the adjacent side divided by the hypotenuse, which is 20. So x will be equal to cosine inverse of 7 divided by 20. Use your calculator, press this one. And lastly, you can see we have a hypotenuse and we have opposite side because it is directly opposite to the acute angle. So we use sine here. So sine of that x value is equal to opposite divided by hypotenuse. Therefore, x equal to sine inverse of 42 divided by 48. Just use your calculator, press everything here. Let's move to the next one. These questions are so much similar. You can see that this is the opposite side and this is the adjacent side. Use tangent of x equal to opposite, that is 2.5, divide by the adjacent side, which is 2.8. Take tan inverse of both sides. We have x equal to tan inverse of 2.5 divide by 2.8. Use your calculator, press everything. You can do this one. You can see that this is hypotenuse because it is directly opposite to the right angle, and this is opposite, which is missing. This is adjacent. So the relationship between the adjacent side and hypotenuse is cosine. So use cosine of x equal to 11 divided by 15. Take cosine inverse of both sides to find the value of x. Do the same thing here. This is opposite. This is adjacent. Use tangent. That is tangent of x equal to opposite divided by the adjacent 1.2. Simplify and get the value of x. All right, this time around you can see that all the reference angles are given, 35, 40 and 70. So we need to find the missing side. And how can we do that? First of all, you should know that this is the adjacent side, this is the opposite side. So what relates them? The relationship is tangent. So tangent of 35 degrees will be equal to what? Opposite divided by what? Adjacent. So we are going to make x the subject by just switching tangent of 35 degrees with x. So just switch them. You have x equal to 10 divided by tangent of 35 degrees. So if your calculator can take the whole of this together, you can do that. If it cannot, you can further break it down as x equal to 10 divided by what is tangent of 35 degrees. You should do that first. According to my calculator, it is approximately 0.7. All right. Then you take 10 divided by 0.7. That is approximately 14.286 in 3 decimal places. Remember that this is not an angle. It is a side length and the unit is given as cm. So you move to the next one. What is the relationship between the hypotenuse and the opposite side? Because this angle of reference, the side length directly opposite to that angle of reference will be the opposite side. So this will be sine of 40 degrees equals opposite divided by hypotenuse, which is x. So x will be equal to 8 divided by sine of 40 degrees. So use your calculator. If it can take all these values together, just press 8 divided by sine of 40 degrees. And according to my calculator, this is approximately equal to 12.4 in 1 decimal place. This is centimeters. Then the last one here, you can see that this is hypotenuse, the longest side, and this is adjacent side. What is the relationship? Is cosine. So we have cosine of 70 degrees equal to adjacent side divided by the hypotenuse, right, which is 6. So how can you make x the subject? By multiplying both sides by 6. Therefore x is equal to 6 multiplied by cosine of 70 degrees. So 7 multiplied by cosine of 70 degrees is equal to approximately equal to 2.4 in 1 decimal place. Let's move on. You can do all of this. This is opposite side. This is adjacent side. Use tangent. Let me just write it for you here. Tangent of 22 degrees is equal to opposite divided by the adjacent. Make x the subject. X equal to 18 multiplied by tangent of 22 degrees. Use your calculator, find it. This is opposite and this is adjacent. The same thing, you use tangent. Tangent of 31 degrees is equal to opposite, which is 2.8 divided by adjacent, which is x. How can we make x the subject? you just switch tangent of 31 degrees with x. So x will be equal to 2.8 divided by tangent of 31 degrees. And lastly, what we have here, this is hypotenuse, this is opposite. So you use sine of 55 degrees is equal to opposite divided by hypotenuse. Make x the subject. X will be equal to 77. No, this should be 75, right? (75) multiplied by sine of 55 degrees. All right. I think you're going to do all of this. This is acute angle. This is opposite. This is hypotenuse. So we're going to use sine. Sine of 60 degrees is equal to x divided by 50. Make x the subject by multiplying both sides by 50. So x equal to 50 multiplied by sine of 60 degrees. So use your calculator, press sine of 60 degrees, which I think is 0.5. You multiply by 50, that will give you 25. So x is 25 centimeters. This is hypotenuse. This is adjacent side. Use cosine. This is opposite. This is adjacent. Use tangent. This is opposite. This is hypotenuse. So it means that sine of x is equal to 8 divided by 9. And x is equal to sine inverse of 8 divided by 9. And what about this one? This is hypotenuse. This is adjacent. You use cosine. Cosine of 25 degrees is equal to adjacent 3 divided by hypotenuse x. So x will be equal to 3 divided by cosine of 25 degrees. Compute it. And lastly, we have the adjacent. No, this is opposite side. This is hypotenuse. So use sine. Sine of 59 degrees is equal to opposite divided by hypotenuse. Make x the subject. You have x equal to 20 divided by sine of 59 degrees. And I think, okay, we have other questions here. You can do all of this. This is in kilometers. This is opposite. This is hypotenuse. This is adjacent. So since the adjacent side and the hypotenuse are given, you use cosine. Cosine of x equal to adjacent divided by hypotenuse. Make x the subject by taking cosine inverse of both sides. This is opposite. This is adjacent. Use tangent. Tangent of x equal to opposite, which is 3.1. Adjacent is 5.1. Take tan inverse of both sides to find the value of x. And lastly, we have opposite and adjacent. This is tangent as well. We have tangent of 30 degrees equal to opposite 9.3 divided by x. So x will be equal to 9.3 divided by tangent of 30 degrees. Use your calculator, compute. And I think this is all I have for you today. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.